This live Slooh show is brought to you by the support of Slooh members and the following sponsors. Visit slooh.com to become a member today.
Well, hi everyone. This is Slooh. I'm Bob Berman, and wow, what an eclipse that was. We're here to summarize it, review it, think back, share our moments of it, and bring back some of our special guests and little clips from our interview with the Vatican astronomer and some of the cool things that unfolded over that epic 5-hour show. Whoa, there were so many people that were there that night that some of you, it depends on how you watched us, whether it was live stream or on the slooh.com. It depends on how you watched us. Some of you had freeze up problems just because there were so many. Other people saw it flawlessly. However, it was when you joined us, we're so glad you did. And the comments that we've gotten showed that some of you were watching the eclipse and dashing in and out to hear our experts and our live commentary in between seeing it for yourself live, which of course is always the best way if you can, if you have it in your sky. Other people had cloudy weather and were even more happy to join us here on Slooh because we brought you the eclipse that you otherwise would not have seen. We're going to bring you some of the best images. Look at this montage from that day. This was a series of pictures that Slooh and our Slooh partners, because we were bringing feeds from really all over the world, 3 continents, 30 different observatories and places, and we had feed partners in Canada and Europe and South Africa and the Canary Islands, all over the place. Look at this. This is really showing you Earth's shadow. See that? We can see the color of Earth's shadow, that nice red. We see the moon on the right side as it was going into the shadow. Then there's the total eclipse. You can see it fully red. But notice that it looks brighter on the bottom, almost as if it's not fully eclipsed. That was one of the edge effects that we're going to talk about shortly. And then on the left side, the partially eclipsed moon as the eclipse was winding down. So we got it all. We've got it all. So we're going to summarize it, not for another 5 hours the way we did that day, but we'll bring you sort of the best of, roundup of what we saw. And one thing to look at is there is a white going to, I don't know, what would you call it? Orange, coppery red. Certainly not really a blood red, but one of the things we enjoyed discussing with people who were watching it and all the people who sent us their reports while it was underway and afterward, their timings, because we were looking for the moment of hemogenesis, a word, a newly made up word actually, that means when did the moon go from looking black to looking red? Because when it started out as a partial eclipse, it looked like a black bite. This looks darker. You can see a trace of red here, but it looked like a dark gray or even black bite was being taken out of the moon. And then at a certain point, as we approached 10 o'clock Eastern time, and people were giving us their timings to the minute, it was so cool, we saw it change color. So some of these different colors of the moon were so fascinating, and they're caused by different atmospheric layers. We'll talk to an expert on that from the Canadian Weather Service coming up in just a few minutes from now. And before we even do that and summarize this great eclipse, which happened in hour-long chunks. There was an hour of penumbral eclipse, which means essentially the moon only subtly changes its darkness because a lot of the sun is still hitting it. Then we had 1 hour or so. It actually lasted from 9:06 to 10:11 Eastern Time, a little over an hour of partial eclipse when the moon went through a series of bizarre-looking phases as it was going into the shadow, and then we had totality lasting for an hour and 13 minutes too. So roughly an hour for each one of these events. Let's now take a little highlight reel of some of the events that we looked at, and we'll go now and look at the edges of the eclipse moon, in other words, Earth shadow, and see what we see with them. So let's go and take a look.
You've heard the media hype. It's not just hype. It's really happening. The largest moon that is going into eclipse until the year 2033. The mega moon, the supermoon, the blood moon, even NASA is calling it that, and the harvest moon, all combined into one package that's falling into Earth's shadow.
But lunar eclipses only ever occur during a full moon. That's because the Earth has to be between the Sun and the Moon so that it can cast its shadow out into space and onto the Moon. Why is it then that we don't see a lunar eclipse every full moon? Well, the answer is that the Moon's orbit is tilted with respect to the plane of the orbit of the Earth around the Sun, and this means that at some full moons, the Moon can be sitting outside of the Earth's shadow. But that's not the case tonight. Tonight, the path of the Moon takes it into this long cone of darkness which is cast by the Earth out into space.
I'm out in my garden, would you believe? I've got my telescope behind me and I'm imaging the eclipse, and it's fantastic. I can see up there. In fact, the northwest limb is really dim. Just since I've been, talking to Trish, our producer, it's really started to dim.
For some reason in the astronomy world, we have all sorts of end of the world Armageddon type experiences almost every year. Some people think there's a hidden planet named Nibiru that's on a collision course and it's going to collide today during the eclipse. Others think it's later this year or next year, but you'll see a lot on the web about that. In truth, no, NASA and the world's astronomers are not hiding some cataclysm. I've been connected with astronomy all my life, and I can tell you that these are blabbermouths. Astronomers would never keep anything hidden. They couldn't.
We was talking about the end of the umbral phase, the sort of the moon's sort of starting to peak out, and I'm looking around, and there's almost kind of like like a sort of diamond ring effect, that the moon is so dark on that right hand side. As I look at it, the bit that is actually sticking out is really quite pronounced. So maybe, what was the name you gave it, Bob? The heme something?
A hemogenesis, that's the start,
That's
the
it.
beginning, the birth of the red part. But now this is the end of it, so now we need another Latin phrase for we'll look for when the red part is over. In other words, when our eyes, when our cameras, when our CCDs, in trying to capture the moon correctly, when there's so much moon that has returned, all bathed in sunlight, that the cameras have to be stopped down, and we underexpose the red, and it becomes black again. And maybe the name for that would be the onset of darkness, rather than putting it in the negative at the end of the redness, maybe the beginning of darkness. Although that does sound a little morbid, doesn't it? It's like
Sounds like a film title, I think.
It's not faith in the biblical sense, but there is an underlying faith that an astrophysicist has that the numbers, the symbols, the expressions that are being used actually work the way you think that they're working. And speaking precisely to what you talk about is that we have these realities that we give names to, such as water. But at the same time, there's also that exploration of human reason and refinement of human reason that has contributed to that language and will change the language in the future, and will refine it even further and give us a better understanding of the natural world. And in that process, we'll also be able to get a better understanding of the divine and of God, in terms of, as we better know how the universe works and how the world works, it gives us a deeper sense of our understanding of the source of that universe and how that source relates with us.
Well, that was some of our peaks at our highlights that day. We're going to keep looking at others. We're going to have back at least one of our experts who were on that day for a reprise and a wrap of that great eclipse. And what a thing, right? I mean, we had a mega moon. Some called it a super moon. We had the blood moon. We had the harvest moon, all rolled up into a single event, something that's not going to happen again until the year 2033. Of course, every eclipse is its own eclipse, special in its own way. This one in the constellation of Pisces, which had extremely faint stars behind it, it was fascinating to watch the eclipsed night go from a full moon brilliance, full moon casts so much light on the countryside, to watching all the stars come out and the Milky Way appear and the night get transformed. The thinking among astronomers is that this was a little darker than average, in case you wondered how it stood in terms of the redness. It was a nice deep red. It wasn't just a barely pinkish orange eclipse. So it really caused a big shift in the background. And that brings up our topic of what are called edge effects, sometimes called edge events, because we're talking about the edge of Earth's shadow. The middle of the shadow, well, that's the part where a lot of red light, really the combination of all of Earth's sunrises and sunsets, beautiful, poetic, get combined and focused into a single ruddy color that hits the moon. But because different layers of the atmosphere are responsible for this light being refracted around, you can have various colored effects. Now, some say that they've seen even blue. I've seen that in photographs, but I can't honestly say that in all these years I've ever seen any blue on the eclipse moon. But some say they see it. We're going to bring um, Scott Sutherland back, and he's one of those who advocates, at least on photographs, a bluish appearance, and wonder if he ended up seeing any of those that day. You know, we were talking to him during the event about these so-called edge effects, and why don't we go and replay that and see what that conversation was about as a way of reviewing this eclipse. Edge effects. Let's go and revisit that.
Scott, we're also going to talk about these odd so called edge effects caused by the fact that the redness is not uniform. It's odd, it's uneven, it's caused by our atmosphere. What's up with that? What's going on here?
Well, basically, the darkest part of the atmosphere, at least when you're looking at it edge on, is the lowest part, the troposphere, which is where most of our weather occurs. And if you look at this edge on, like say from the International Space Station, and their views of it, you can see this quite often, is that it's red at the bottom, and then there's a sort of a whitish pink layer in the middle, and then it goes off to blue at the top. And exactly right there on the screen. So that's a picture of the Space Shuttle Endeavour from, I believe, 2007, taken from the International Space Station. And you can see the layers very clearly there. So that's the orangish red troposphere at the bottom. Then you have the stratosphere in the middle and the mesosphere above that on top with blue. Now, the blue seems to mainly come from the fact that ozone absorbs specific wavelengths of light. And so it will pick out the reds, and so you'll only get the blue coming through when you're looking at it edge on like that. And as the light filters through the atmosphere, because the globe is curved, this acts like a lens, and all of that light gets beamed into the umbra, because the umbra itself is just a dark blank patch of light because the Earth is physically blocking the sun. But because of this focusing, the lens of the atmosphere focuses all that light, the different stratified layers of color, into the umbra. And the very center of it turns into a big circle of reddish orange, coppery color, as you mentioned. And that's what we mostly see when we see a full total lunar eclipse.
Okay, so for our listeners, let's translate that. Umbra means Earth's dark part of the shadow. That's the part of our
Right.
shadow where no sunlight is hitting the moon. And
That's right.
what Scott is telling us is that our atmosphere is being bent, refracted onto the moon. Actually, what we're getting on the moon, the reddish color, is really the combination of all of Earth's sunrises and sunsets. Very lovely,
Yes,
poetic idea being combined into a single kind of light. And the uneven color, as he's explaining, is due to these effects. Why don't you help guide us a little bit on these final 2 minutes of sunlight? What are you seeing now that the rest of us should be paying attention to?
well, this view of the moon from the United Kingdom is actually a really good one because it's very close up. And it's, again, really hard to see these things because, I mean, we're just looking at the contrast between the very, very bright little edge of the moon on the bottom there and the rest of it, which is getting darker. But if you really focus on the part that's right on the edge of that brightness, you can almost catch a bluish tinge. It's very hard to detect.
And we've got it. We've diced it up. Here is, we've reached hemogenesis, the moment of the blood moon's beginning. Actually, we've been seeing it looking red, of course, as we've approached totality, but here we are. We have reached totality. Look at that yummy, scrumptious unevenness in the lighting on the moon. And this is something that is not an artifact. If you go out and look at the moon yourself, if you have clear skies, and we urge you here at Slooh to glance up, even use binoculars, and see for yourself this great uneven lighting on the moon. It looks like it's not totally eclipsed. It looks as if part of the moon is still receiving full sunlight, but it is not. So why don't you explain to us again how the different parts of the atmosphere are producing this unevenness, Scott?
Well, basically, it's due to the density of the atmosphere at the different levels. So down in the troposphere, it's the densest part of the atmosphere, thickest part, and so there's more molecules of air in the way as the sunlight passes through that it gets scattered more. And since light scatters starting at the blues and going towards the longest wavelengths, the only ones to really make it out the other side and get focused into the umbra are the oranges and the reds and the infrared if that makes it through as well. Then after that, the higher up, there's less air there, less molecules, more light gets through. But as you go a little bit higher, that's when the ozone starts to actually capture some of those wavelengths and completely strip them out. And so that's when you get that
Wow.
blue color that can creep in on the edges.
So that was part of our conversation with Scott and that night. And you know what? We're going to bring him back right now for a kind of wrap and discussion of these odd events that we saw on the moon a couple of days ago. So, are you there, Scott? Are
I am
you?
here. Oh,
Can we talk to you?
yes. Hello.
Great. Now this is Scott Gordon. We're glad to have you back. You're with the Canadian Weather Service. Is that correct? What's the exact name of it?
The Weather Channel, or the Weather Network.
The
I'm sorry. Canada's
the
Weather Network.
weather. Okay, the Weather Network. And Scott, you know what we're doing, of course, right now is live in real time. We're summarizing that great event that so many people joined us for, and
Yes.
instead of taking the full real time 5 hours on it, we're looking back, because it's going to be a long time before we have that confluence of mega moon, blood moon, harvest moon, all the unusual things that came together. So as that eclipse went on, even after your segment was over, we left off when totality was just beginning. But you continued to observe. What did you see, and what were the edge effects that that you observed that night?
Well, from here in Oakville, Ontario, which is just to the west of Toronto, we actually were completely clouded over for most of the eclipse, unfortunately. We did catch about maybe 20 minutes of the eclipse towards the end of totality, but when it was going to slip out of the umbra. And so we caught it then, so we had some pretty good views then, but it was I missed totality, and it was hard to catch those edge effects looking at it in person. And not that actually, I think that you probably wouldn't see these effects, as you've said, in person, just looking up at the sky. The moon is just too small. It's too much of a contrast between the penumbral part of the eclipse and the umbral part of the eclipse to catch these color differentiations. It's really only in the photographs that you're going to see that, and or the telescopic views for that matter.
Okay, so as the eclipse went on and we brought the feeds from different parts of the world, what was your summary of this eclipse compared to, let's say, the average one you've seen? How would you rate this on a scale? Was it darker or lighter than the average one? What do you think?
Definitely darker, given the fact that it's the perigee eclipse or supermoon eclipse, much closer to Earth than usual. It would have been deeper into Earth's shadow, and so it would have gotten more of the dark shadow, more of the dark red than any of the other colors. So definitely darker than the others that I've seen.
Well, that's an interesting point. I've heard other astronomers as well assess this, and so did I, that it was darker than the average eclipse. However, we thought that this was just random dust or cloudiness or some other effect like that. It's interesting that you're pointing to the fact that the moon was at an extreme perigee. It was closer to Earth and therefore further into our shadow. That I didn't even think of that. But our listeners now, of course, Earth's shadow tapers like a chopstick. It gets narrower and narrower as it goes into space. So if the moon is penetrating the shadow at a closer point to us, it will penetrate a deeper part of the shadow than usual, and deeper into a blockage of the sun will produce a darkening. This is so that makes sense. So you attribute this to the fact that it was a perigee eclipse, that that's what made it darker.
Mostly, yeah. I mean, you mentioned it before as well that back when Mount Pinatubo erupted, there was a lot of particulate matter and ash thrown up into the atmosphere, up into the stratosphere, and so that darkened that particular eclipse that happened in that time period. And that certainly can happen and does happen quite often. Forest fires, just storms, hurricanes, normal thunderstorm activity can scatter more light as it passes through those edges, through the all the accumulated sunsets that you talked about earlier, and that can darken the eclipse on its own. But in this case, the distance that the moon was from Earth being much closer than usual, yeah, I would attribute most of it, anyways, to being closer, being deeper into the eclipse or into the shadow.
Good. That's very interesting. Now, since you're bringing up the moon being closer, and since the media called it a supermoon or a mega moon, I think honestly, when people observed it, considering it was only 7% larger than the average size or 14% larger than the very smallest moon in early March of this same year, it was theoretically right on the edge of what anyone could even notice. Now, before it got clouded out for you, were you able to perceive the moon as being larger than normal, or was that not perceptible?
I wouldn't say that it was. I mean, it's hard to tell just because you don't have a comparison. We had two moons in the sky, and they were roughly the same size, and they were the same distance away. which would be impossible. But at the same time, if they were up there and one was just at the apogee type distance, the one was at the perigee, you could have the comparison between the two to really tell the difference. In this case, it's just too small of a difference to tell. Now I could really tell the brightness once the moon had passed out of the umbra and it was just the perigee full moon, and skies had cleared out here. You could really tell a difference with the brightness of the moon, but the size of it, no, not so much.
Yes, yes, that was our observation too. So the size would be 14%, the brightness would be 30%. So
Mhm.
that is something that would be closer to be noticeable. That 30% corresponds to a healthy fraction of one magnitude, and the full
Exactly.
moon's average brightness is minus 12.6, so that would bring it to minus 13, and that should have been noticeable. And according to our expert, Scott Sutherland, it was noticeable in the eclipse. But I think most people, having heard the media, mega moon, super moon, largest moon of the year, which it really was,
Mhm.
had to have been a little bit deflated if they actually looked up in the sky and said, well, I don't know, that moon looks pretty much like a full moon. So that was
Yeah.
the aspect of it that we warned people about here at Slooh, that the colors will be dramatic. The fact that the moon is occurring during its perigee, that fact alone makes it very cool. But as to a physical visual effect where we can look up and see this enormous moon in the sky, no, don't hold your breath for that. What other thoughts, Scott, about this eclipse? You know, it's going to be a couple of years before we have another. Um, what comparison between this are you perhaps looking forward to and the next one?
Well, hopefully I'll still be around for the 18 years from now when the next perigee um, harvest moon eclipse comes up, or super harvest moon eclipse comes up. Um, but so far, I'm actually looking forward to seeing more of the partial eclipses so that I can try to catch more of those edge effects. Um, so when the next ones are coming up, I mean, this is the end of the tetrad, so the next eclipse that we have will be a partial eclipse. Now, I haven't looked it up yet to see exactly where that'll be visible from, but I'm sure that there'll be plenty of coverage from around the world, from Slooh and from other people who will broadcast it over the web and take pictures. So I'm really looking forward to seeing those to catch those edge effects as well.
Good, and us too. And of course, here at Slooh, we'll bring you every eclipse that happens because that's what we do. Scott, thank you for coming back and wrapping up the eclipse a little bit with us on this live show several days after the event, where so many people tuned in to join us. And your participation on it on that first night was really helpful, and I think added a lot for people. So thanks a lot for that. Meantime, we're going to go to some of our visual highlights from the eclipse. Let's go back and kind of review that for the next few minutes, then we'll come back and do something else. I'm back. This is Bob Berman. This is Slooh, and we're doing a live wrap-up show of that great Mega Moon, Harvest Moon, Blood Moon eclipse. You know, it was all the rage. The media, I think, weren't quite prepared for the number of people who were attending to it and watching it. And here at Slooh, wow, we had so many crowds that our server was at times a little jammed up, and we have special ways of handling any amount of web traffic. It was really great that day. I want to also make note that this was an international effort. We had Trish in our main studio in Connecticut, who was responsible for that very, we used to say in the old Woodstock days, trippy, far out, new age, meditative, celestial, electronic type music that I think was just perfect. And so, for the first time, when we presented an extended event, a celestial event, in the past, we've always had experts and talking and nonstop narration, and that's good. That's science, geeky stuff. But this time, for the first time, we interspersed this, and this was Trisha's idea. I thought it was great, with periods, 5 minutes long, 10 minutes long, of appropriate music that was soothing and calming and celestial and went along with the majesty of the event. It really brought out, I think, the depth and the feeling, the flavor of the moon passing into Earth's shadow. At the same time, we saw different shades of red. Now, that was not through some trickery or filtering. We used no filter. None of our Slooh telescopes and none of our feed partners used any kind of special filtering. What it is, as we all know, sometimes the moon will be lower in the sky, and it was lower for some observers than others. Sometimes the conditions will be a little bit more moisture, a little bit more dust in the air, and that will produce a deeper red than those who had the moon under drier and higher skies. So look at the different shades of redness that we got. There was no right and wrong except for what you may have seen yourself. If you had clear skies and went out, the color of the moon and the way it looked for you, that was the truth. So I asked several times during the show, how does that compare to our various Slooh feed partners and our Slooh telescopes? Because you can see, look at this image right now that we're showing you, that here it's more of a coppery red and maybe more like a penny slightly. And in some of our other images from the feed partners, it almost matched the blood red description that you heard so much in the media. It never quite, of course, got blood red, but here, for example, is a deeper red. This was not wrong either. The moon really looked uneven in lighting. Traditionally, you would expect the top of the moon, which was more central in Earth shadow, to be darker and a deeper red, and the bottom part of the moon, even during the total part of the eclipse, during the early part of the total eclipse, to be in so much indirect sunlight, not direct sunlight, that it would look more yellow and almost white, depending upon the exposure. And that's what we saw. That's what our observers saw as they dashed in and out of their houses and joined us here at Slooh. It was tremendous. It was really, really great. We just talked a moment about the Slooh team. We had members, our Slooh astronomer Will Gator in Britain. We had Paul Cox. I don't know if I should be telling you this, the inside word, but we were set up with very special equipment to bring you this eclipse from the Stonehenge monument live. And he was there, and it was just unable to connect with enough of a signal to bring that to you. But, next time. It just shows what lengths the Slooh team goes through to bring you just a stunning eclipse, and we're so happy with how it came out. One new feature was the golden record, and you know what? Well, let's run a little bit of that golden record sequence, and I'll show you what I'm talking about.
The moon and the sun, as the biggest and most obvious objects in the night sky, are the centerpieces of ancient cultures worldwide. We explored some of the ones surrounding the sun earlier this week during our equinox show, but tonight it's all about the sun's nighttime sibling, the moon. In a number of cultures, they actually were siblings. The Greeks at one point had the twins Artemis and Apollo to represent the sun and moon respectively. Taking a look at the full moon golden record, we can find a bunch of other cultures with their own beliefs about the moon. like the Korean story about how the sun and moon were created, which bears a resemblance to the story of Little Red Riding Hood. According to the story, a tiger chased a brother and sister up a tree after eating their grandmother and dressing in her clothes to get a bigger meal. The youngest, the sister, prayed for a rope to come down from the sky to save them, and when it came, they were placed in the heavens, the boy as the moon and the girl as the sun. Being so close to the Earth and so much more changeable than the sun, with its many phases, changing size, and effect on the tides, and if you believe the rumors on people and animals, it's no surprise that the moon would have a place in the hearts of poets. There are plenty of songs and poems about the moon, some of which have made their way onto the Golden Record, and a couple that I want to share with you today. First up, we're probably all familiar in some way with Emily Dickinson and her interesting relationship with capital letters. In the mid-19th century, she wrote a poem called "The Moon is Distant from the Sea," a short piece that speaks of the moon and its command over the sea, as if from two lovers. The moon is distant from the sea, and yet with amber hands she leads him, docile as a boy, along appointed sands. He never misses a degree. Obedient to her eye, he comes just so far, toward the town, just so far, goes away. O Signor, thine an amber hand, and mine the distant sea, obedient to the least command, thine eye imposed on me. That poem has been read and arranged many times over the years and has even become a song performed by choirs. You can listen to one of those arrangements on the Golden Record right now. Just go to Slooh's homepage to find it. But of course, this is an eclipse, and the drama of something like tonight has certainly inspired poets on its own. Poets like Thomas Hardy, who wrote this piece called At the Lunar Eclipse. Thy shadow, earth, from pole to central sea, now steals along upon the moon's meek shine, in even monochrome and curving line of imperturbable serenity. How shall I link such sun-cast symmetry with the torn, troubled form I know is thine, that profile placid as a brow divine, with continents of moil misery? And can immense mortality but throw so small a shade, and heaven's high human scheme be hemmed within the coasts yon arc implies? Is such the stellar gauge of earthly show, nation at war with nation, brains that teem, heroes and women fairer than the skies? These are just a few of the many selections that you can find online, in poetry books, everywhere, of artists connecting themselves with the things they see in the night sky and expressing confusion about their own lives here on Earth with metaphor about the moon and the sun and the stars. If you know of any and you'd like to add them to the Golden Record, all Slooh members are actually able to log in right now. Just go to Slooh's homepage and click on the Golden Record link, and you can see all of the many things that we've added to it, and of course add your own.
Cool, right? This is Bob Berman back again with our live Slooh wrap-up of the great 2015 final member of the Tetrad total lunar eclipse. You know, a tetrad is when 4 total lunar eclipses occur in sequence. That's the most that can ever happen, because every 6 months is another eclipse season, meaning that the tilted plane of the moon's orbit is again aligned with the sun and the earth, and so an eclipse could happen. 6 months is the soonest it could happen. But the next eclipse, 6 months after a total eclipse, could be any type. It could be partial, it could be penumbral, which is barely there at all. But if there is a follow-up total eclipse, well, that's very cool. But what about 6 months after that? Hey, what if there's another one? Now, that's unusual. And then what if you get a fourth 6 months after that? Now you're rare. There has not been a tetrad, as such a sequence of 4 total lunar eclipses in a row is called, at all. Not one from 1600 to 1900, 300 years. So at that time, they were more than rare, they were impossible. But now in the 21st century, the celestial geometry is just right that we do get occasional tetrads, 8 of them this century. And this was our first. So there we had it, the first tetrad, 4 total eclipses in a row. And the one that we just had last weekend was the 4th and final member of the tetrad. So happens it occurred at the most convenient hour of all of them. It was closest to us of all of them, so we finished with a bang. That was really, really special. And we did some unusual things. The celestial music, the, I think, very highbrow poetry and the connection with myth and lore and legend and mythology instead of just science. Uh, Boy, I thought that really raised the show. I had nothing to do with that aspect, but I'm in awe of it, and my hat is off, and I salute in every other possible cliche about that. Adding that touch to a 5-hour event. We're looking at some of the eclipses that we took during the partial phase. Look at those mountain ranges. See that curved mountains? Those are the lunar Apennines, the tallest mountains on the moon, right there almost in the center. And notice how they curve down and to the left to a bright white spot, which is the crater Copernicus, arguably the most beloved of all the lunar craters. Looks like a white spot with white lines radiating from it, an impact right in the middle of some solidified frozen lava seas. At other phases of the moon, other than full, it shows stepped walls. It looks like Asian rice paddies leading down to a giant smooth crater floor with two giant mountains and one smaller one on that sticking up from it. So a very, very special feature. And we watch these features as the moon's shadow swept over it. Another thing that happened during the eclipse was we took advantage of the Pope's visit to the United States to talk with a Vatican astronomer, a spokesperson who's a knowledgeable in astronomy itself. And we, normally don't do that because this is a science show and we keep religion out of it. But the world was so united in watching this event. And the event we watched concerned the world because it was Earth's shadow that was enveloping the moon. So, in all these ways, it was a unifying event. And we couldn't resist the fact that since at that time the Pope was making headlines with very unifying messages in the United States, we thought that speaking with the Vatican astronomer would be just perfect. And so, of course, this has more of a spiritual bent to it than we're normally going to put forth. But I thought it ended up quite lovely, frankly. And let's play just a little clip from that again to review. Again, where we are doing just that. We're summarizing, synopsizing the great lunar eclipse. 5-hour show in real time here at Slooh. And what we're doing right now is just looking at highlights of it in case you were there and want to recapture them, or in case you missed it and want to see it for the first time. So let's look at a little bit of this interview that I did with the Vatican astronomer, because it was kind of cool and unusual.
Some people believe that faith and science are mutually exclusive endeavors.
Right.
Now, as someone whose work crosses both of those fields, I'm speaking about yourself.
Yeah.
Do you agree?
I disagree. I mean, when you look at the nature of faith and the nature of science, at the core of both of them is truth. And the exploration of truth is to uplift the human person. John Paul II has a beautiful encyclical entitled Fides et Ratio, and that's Latin for faith and reason. And the very first line of Fides et Ratio is that faith and reason are the two wings of which the human person ascends. And so, therefore, if we understand the relationship properly, being that science limits itself to the study of the observables, the study of the material, the study of those things we can measure, those things that we can understand in terms of the material world, there's no conflict. And if anything, that the church should be emphasizing, we need to develop our reason. We need to explore science on its own terms, not in terms of what sometimes very sincere Christians, but unfortunately, in my opinion, some Christians that don't have a terribly healthy understanding of how to do this, they try to either fit science into the scriptures or they try to fit scripture into science. And both of that just creates an intellectual mess. You end up reinventing errors that the church has had committed for centuries, such as making God one being within creation. If you want to try to have a clear, trying to fit scripture inside of a scientific metaphor, in terms of a scientific structure. When we look at God, God is not a being in creation, but being itself. God is beyond time. God is not conditioned to time. And so therefore, when you understand the true relationship between the nature of faith and the nature of science, they're really a complement to each other, and is necessary for the person to embrace, to grow in knowledge. And so therefore, a Catholic Christian should have no fear of studying science on its own terms, because science is an exploration of truth. Faith is an exploration of truth. And if you are exploring the truth, you are ultimately seeking after the source of that truth. And from my Catholic tradition, that we clearly see that leads us to, the origin of our understanding of God as the source of all truth. So there's a lot more that could be said, but that's a little bit of a Reader's Digest answer to your question.
Father James, you mentioned eternity a few times
Yes.
in this last segment. Now, in cosmology, and many of our Slooh members controlling the giant Slooh telescopes, of course, are fascinated with the larger issues of the universe, including where does it end, how does it extend. And in recent years, there's been some data, such as the Berkeley team in 2013, indicating that the flat topology of space may indicate that space goes on and on and on, and that it's infinite, and that going in the other direction with the Big Bang, we certainly don't know what preceded that, but there are some suggestions that the universe may be eternal. That's the word you used. Now, is an eternal universe, or one that's infinite in extent, certainly it's beyond what our minds can grasp, is this compatible or incompatible with church doctrine?
Very good question. And correct me if I'm wrong, because this is where perhaps some of my deficiencies in science may show up. So at any time, Bob, you feel you need to correct me on any of this, feel free to jump in. But from my standpoint is that when we look at the created world, we see time as a dimension. And so therefore, when we understand in a scientific sense, the understanding of something that goes on forever, something that goes on infinitely, it's still within the context of a world of time, of which that dimension is present. When we speak of the infinite in the divine in terms of God, we see an existence that is not conditioned by time, that is not conditioned by any of the material dimensions of the world. And so therefore, there is a difference in terms of, if to borrow a little bit of Wittgenstein, that it's not necessarily the term you use, but what's the definition underneath the term that's being used. When we understand the idea of an infinite God, it's not that there is a divine clock that goes on in heaven that can measure in a never-ending heaven. It's the idea that when you are in that realm of God, there is no time. Time does not exist.
Well, that's very nice. That is actually compatible with the way science has been going. More and more scientists are increasingly leaning toward time just being something that we humans create to make sense of things. Unlike Newton, who thought it was an actual dimension, more and more people are like Immanuel Kant, who think that it's like our numbering system. It's not something that's real, like a cucumber. It's nothing you can examine, and therefore, you certainly couldn't travel through it, and it doesn't have independent existence by itself. So what you're saying is actually more and more in keeping with the way science is going, that there really is no time in reality, and the underlying reality anyway.
Yeah, and that's and thank you for that correction. I appreciate that, because one of the things in theology we're always careful to distinguish is to emphasize that one of the things that I oftentimes see people who are trying to critique faith from a scientific standpoint, a mistake that I see them to make, is that it eventually tries to make God one being within creation, and to constantly go back to that understanding that God is not a being. And it's something that is very hard for the human mind to grasp, of thinking of something, an entity that's not a being itself. And so I appreciate your correction, in terms of the understanding of time. So thank you for that.
No, that's in keeping with the line of passive understanding, isn't it? I think this,
Yeah,
what we're talking about, really does passive our human symbolic language, where we have words for
yeah,
things. I mean, actual water is not the word water, so we try to understand things with our symbolic representative language, but it's becoming clearer and clearer that there's an underlying reality that's beyond what we can even think. I
yeah.
think
It's
that
interesting
there's.
you say that. A former classmate of mine from seminary, Father John Carchi, was just named rector of Mundelein Seminary, and he was an astrophysicist. He received his PhD from the University of Chicago. And for me at that time, being that I was just an infant at that point of trying to understand intellectually this relationship between faith and science, I had a conversation with him, being that here's an interesting guy. He's an astrophysicist, but also studying to be a priest. How do those two work for him? And precisely to your point, when I was all curious about, how does he see this all fit together? One of the things he shared with me in reflection was, he's like, James, one thing you have to remember is that it's not faith in the biblical sense, but there is an underlying faith that an astrophysicist has, that the numbers, the symbols, the expressions that are being used actually work the way you think that they're working. And speaking precisely to what you talk about, is that we have these realities that we give names to, such as water. But at the same time, there's also that exploration of human reason and refinement of human reason that has contributed to that language and will change the language in the future, and will refine it even further and give us a better understanding of the natural world. And in that process, we'll also be able to get a better understanding of the divine and of God, in terms of, as we better know how the universe works and how the world works, it gives us a deeper sense of our understanding of the source of that universe and how that source relates with us.
Fascinating. We've been speaking with Father James of the Vatican Observatory. We're doing this here at Slooh because this is the day of the lunar eclipse that's uniting many, many people in the
Mhm.
world, looking at an event that the moon and the earth are both intimately involved in. And so, of course, here we are all together, very much concerned with our planet Earth and the issues that extend beyond it. So, this was a fascinating discussion. We're really in your debt for you joining us here today. Thank you. And perhaps we'll speak to you again in the future. We appreciate you coming on.
Thanks, Bob, and thank you for everything you do. I'm a Slooh member, and I remember just watching your little clips that you have when I would schedule time on one of the telescopes in the Canary Islands or in Chile. Just listening to your 5 or 10 minute explanations of these objects really helped me understand the universe and nebulas and stars. And so thank you for everything that you do. And on behalf of the Vatican Observatory and the Vatican Observatory Foundation, I just thank you for inviting me on. I deeply appreciate being a guest on your show today.
Well, wasn't that sweet? Wow. In case you just tuned in and wonder what that was about, I mean, have we suddenly become a religious TV station or something? No. But I thought that was really nice and appropriate. And, we went everywhere with this eclipse. It was a 5 hour event. What we've been doing now is distilling it down to 1 hour of some of our favorite images from our many, many feed partners, plus the Slooh observatories themselves that were busy bringing you real time images, and our staff in England and Connecticut, the mountains of upstate New York. That's what we've got. We've got our great solar astronomer for a show coming up that brings exquisite real-time views of the sun through different wavelengths of light. Matt Francis with our Prescott Observatory solar partner there, and whenever anything usual is happening, an event such as this eclipse. Look at this one, by the way. This is a montage of 3 of our Slooh images that night. The one on the right, as the eclipse was partial and the moon was going into our shadow. The one in the middle, showing the moon fully eclipsed, and the one on the left when we were starting to emerge from it. But you can actually trace out the size of our planet's shadow. Now, we start out, we're just about 8,000 miles in diameter. The moon is 2,160, about 1/4 our size. So you can see from the size of the shadow that the moon is in this really fabulous image that the shadow is bigger than the moon. So once the moon goes in, it stays in fully in the shadow for a while. It did for an hour and 13 minutes the other night. But the shadow is not the size of Earth. It tapers down and down, smaller and smaller, but it's still a good half the size of Earth when it reaches the moon's distance of 250,000 miles. Actually, that night the moon was unusually close. Surface to surface distance was only 216,000 miles. That's almost as close as it gets. That allowed the moon to penetrate it even more deeply. So we had all these different live images. We had experts on the show to tell you about different aspects of it. We had one of them back about a half an hour ago, Scott Sutherland of what is the Canadian equivalent of the Weather Channel, bringing you some information about what are called edge effects. That's the different colorations caused by the atmosphere of Earth bending the sunlight onto the surface. I mean, that's why the moon isn't completely black, but has this coloration. Every eclipse is different. You know, you get all sorts of different gradations of darkness. This was a little darker than the average eclipse. Some say quite a bit darker than the average, which is cool. It made the background stars come to life during totality. It made for a more dramatic event, maybe compensated a little bit for the fact that the moon did not appear huge in the sky, even though it was at its closest hour of the month during the eclipse. It was also the harvest moon. During that show, we explain what the harvest moon is, why it's so special, one of only two moons during the year that have a name. The other is the hunter's moon. All the other moons you hear are unofficial: blue moon, wolf moon, strawberry moon. You know, those are either Native American names for various months, full moons that never made it to be called officially a month's moon, or things that have recently gained um, media coverage: the mega moon, the blood moon, the blue moon, and that the blue moon only started in the 1930s. Before that, it did not exist as a separate phrase. So we explored a lot of aspects of the moon in folklore, myth, mythology, its effects on us, and certainly caused the strongest tides of the year. Fortunately, it arrived just ahead of the flooding that hit so much of the eastern and northeastern states. It could have been a lot worse if the a moon had just arrived 2 days earlier, or if the storm had arrived 2 days later. Then we would have really had a mess on our hands. But the timing was pretty good for those things. We did some classy things with poetry and with music, and all in all, we had a lot of fun. So I hope you enjoy our summary, our wrap of that event. There'll be more. Just tune in, look at our timetable, and you'll see that when meteor showers come up, for example, the Geminids, which are expected to be fantastic on the night of December 13th to 14th, when an asteroid comes closer, a comet, and, you know, anything in space, we're there. Slooh is there to bring it to you live, real time, and we'll continue to do so. So, again, hopefully you've enjoyed this summary and wrap up of our great 2015 total lunar eclipse. For Slooh, I'm Bob Berman.